Ah, thank you very much, Vadim. I had the microphone muted and I didn't check it. So sorry for everyone that was watching before. Is it okay now, Vadim? Can you hear me? There is a delay and on the stream also. Okay. So you had the music to enjoy, but you didn't have the explanation. So I'm sorry for that. And let's go over it once more, just quickly, so that you can catch up, so that everyone can catch up. So what I've been saying and doing is that I'm implementing the collide and slide algorithm in a separate project with no netcode and so on to not interfere with the game logic. I started the project with a simple collision, so I'm just doing the collider cast on the distance I want to go through. I'm not actually updating the position of the entity. I'm just doing a debug to say, okay, I was at this position at the beginning. If I don't have any obstacle, I should get to this position, so the green capsule. And then I'm doing the collide algorithm to check if there is something on the path of my entity. If there is, I'm just moving, so I was just moving until the collision, and I'm adding a safety distance not to collide with the entity, the obstacle, because on the next iteration, on the next cast, I don't want to be already touching the wall or obstacle. Otherwise, I will just get instant hit and not move at all. So that gives me my position, my new position that I'm debugging in red. And now what I'm doing is that I'm trying to project the leftover distance on the plane that I've just hit to display the remaining velocity that I should apply. And I'm currently thinking, should I scale the remaining velocity or not? Because right now even that's an issue. Rotation 0, 0, start. Okay, so no, that's okay. But let's say that I'm actually sliding. If I hit the wall perpendicular, I'm actually stopping, which makes sense. But the question is, can this distance exceed the distance that I was left over with? Does that question make sense? I don't think so. Check it like that. No, it's okay. So if I don't scale it and I hit a wall, I will just move slower the more I hit the wall head on. So that makes sense for a wall. Does it make sense for a slope? If this was the horizontal axis, would I want my player to slow down when it goes up a slope? Probably. Okay, let's leave it like that. Reinitialize my cube. And now what I want is to do the iterative part. Because right now I'm just saying I will go into that direction, but I actually want to try to do it using the same algorithm. So I need to do a loop. So let's put that into a for bounce equals 0, bounce below 4, let's say, bounce plus plus. It's here, yes. So here I will try to bounce up to 4 times. I will bounce up to 4 times, but if I'm not colliding with anything, I should stop bouncing. So here I want to continue, and here I want to break out of the loop. So if I just have one hit, I'm not doing the iteration for nothing. I also want to exit. Actually, I also want to exit if the leftover distance is close to 0. So mass dot length squared of the leftover distance is below mass dot epsilon. Let's use epsilon. If that's the case, then I break back. Let's add some comments. Exit the don't try the next bounce if the remaining distance is negligible. Comment on écrit? Ouais. Negligible, okay. Otherwise, continue with the next bounce. There were no bounce, so we can exit without trying anymore, without checking. So there were no bounce, so the path of the entity was not obstructed and we don't have to bounce. Okay. How have you been doing, Vadim, if you are still there, or the other spectators? So we don't want to be exactly at the collision point to avoid having an instant hit on the next bounce cast. Exactly. Okay, we can update the position of the entity up to the collision point minus the safety margin. We still have this distance too. So what's your project you're working on? I'm still having this distance to travel. But we need to reorient the movement along the plane to actually be able to move. Okay. Discovered some strange behavior in physics today. I don't know how to properly call it the physics used in dots. So in dots for me it's called physics, and in mono behavior it's called physics. So it's that's the only difference I have. Let me actually zoom in on the code because I don't think you see it very well. Okay. Vampire survivors with cars. Sounds fun. Is it inspired by something like I think So obviously, TurboMax game is releasing Vampire Survivor clone, let's call it like that, with Space Invader. But I remember a video from Samyam also. She worked on the collab with other content creators, and she made something like that with a car that is trying to roll over plenty of zombies. So is this your inspiration? So let's try. Okay, and if I start again the rotation. Okay, so that's working. Yeah, exactly. Physics versus physics. X versus. There's really some namings that they use that is confusing. There was a webinar this week or last week, I don't remember, this week about distributed authority, and they were defining the notion of authority and ownership. And I don't like the way they are talking about ownership, because for me authority is whatever has control over the state of the entity. So in a dedicated server it's the server, in a peer-to-peer topology it's the host. But ownership is for me, can you actually influence the state? Can you control the entity? So it's related to input and not to actual state truth, let's say. In fact, I saw it as a pet project of a developer from Australia who developed a Fruit Ninja. Ah, interesting. And how is it going? Is it progressing as you expect? So for me, if I want to have a next iteration, I need to update my position. So actually, let's create a var position, which initially is the transform position. And let's use that here instead. Okay, and so that will be my updated position. So I can update the position, update that here, and that should still work the same. Okay, but now I have two arrows. Where did the second arrow come from? It came from the second loop, the second projection, obviously. So I'm updated the position. I have the leftover distance, so I actually need to update the distance itself that I'm traveling. And am I using the distance anywhere after that? No, so I can update the distance. Okay. Will that be it? Okay, and let's duplicate the cube to create another one. And the iteration doesn't seem to be working, because I was expecting to collide and slide on this one too, and it's not. We are developing little by little, but I wrote earlier on the streams, the main thing is productivity. It will not be possible to make MVP without this, and is a delay. Since high performance is already required, everything should be done as it should be from the very beginning. And it takes a long time, but I hope it works. Yeah, I hope it will work for you too. I agree, it's taking a long time to do what you want. And $400 enemies on a phone with 60 frames per second. Yeah. And what kind of phone is it? Is it a new one, or like an iPhone or Android, Samsung? So let's stop them from rotating. And figure out why I'm not colliding a second time. And I've updated my position on the second bounce. I've updated my distance also. My shell is depending on the distance, so that's okay. And can I actually set up? Okay, so I will set up the project in a way that I have two bounds. One bounce and the second one rotation. Okay, so if I play that, I get a fast bounce of the first cube, and then I should collide with this one and move backwards, in theory. Pixel 8 Pro, Snapdragon 7, okay. Is that, I don't know, Pixel 8 Pro, is it a new phone? Let me check. Pixel 8 Pro. Release. Oh, 1 year old phone, so it's not old garbage phone, so it should be okay. But honestly, I'm not sure that you really need to reach 60 FPS on a phone. I don't know. I guess it's up to your requirement, but I'm fine with lower FPS for a phone. So that's set up. Let me attach the editor in debug mode so that we can go through step by step on this collision and understand why the second one is actually apparently not colliding. Ah, okay, it's two different phones. Okay. Snapdragon 7 is a phone? I thought it was like a processor for phones. Snapdragon 7. Ah, okay, I didn't know about this one. Oh, it's a CPU, the Snapdragon 7. No? Ah, okay, it's not the phone itself, it's a Snapdragon 7 phone that is 4 years old. Okay. And both of them are reaching 400 enemy at 60 FPS. Okay. Go. Poco F3 Pro. Okay. I haven't debugged with Rider in a long time. Can I actually step from the editor? From the debugger, so let me check the testing, debugging. What are the buttons in Rider for the next step? Step over and so on. Okay, let's try some. F11 didn't go where I wanted. F10. Okay, F10 seems to be working. Yeah, 60 FPS, so okay. It's a good performance. After that, 400 entities. And did you... So in editor, do you know what takes the most time? Can you profile it to check if it's a CPU or GPU limitation? What is the most consuming system, let's say? So I'm starting from -10, which is, I guess, what I expect. Yeah, it's in debug, so I can't look at it. So I'm starting from -10 and I'm going to 20, -10. To 10, okay. So that's the first situation that's working. So I do have it. I update my position. Okay. I update the distance that remains, which seems to be okay. I traveled 8 units. So my new distance is 11, that's okay. Projecting, drawing the debugs. That's obviously not epsilon, so I continue with the second bounce. On the second bounce, my position has been updated accordingly, so that's okay. And I'm adding that distance. But the distance is not added in the correct direction because I'm still adding it on the same vector, same direction. Profiler shows that with a certain limit of enemies, 2 steps of physics appears in one frame. That is, one system was for 4 milliseconds, and then another system. It already works twice for 4 milliseconds. Yeah, physics will not work with entities. You can't call that in jobs. It's locked on the main thread. And normally the Unity physics should be more performant. I know it is more performant actually. Especially with ECS. So yeah, I'm not sure what is taking so long in your physics cast, but it's worth checking out. So for me, the issue here is that my distance is not actually reoriented. So that's because I need to update the distance after. So okay, the distance need to be equal to the projected leftover distance on the plane. That seems like a good idea. Let's remove the debugs and no, cancel, resume, check, and we do have our 2 collisions. Okay, so we are first collisions, then we are doing this projection along the yellow line, second collisions, and moving backward. So that is good. And I am reducing the velocity every time. I'm still considering if I should or not. So if you are getting ready for bed, Vadim, have a nice rest, nice night, and see you in the next stream, maybe. I'm still working out the schedule because I don't want to compete with other YouTubers, let's say, or content creators. So that's why I didn't do the stream yesterday, to not be at the same time slot as Turbo Max Game with the Hot Pass show. So I need to figure out the correct schedule that works for both me, the audience, and also is not conflicting with other good content creator, let's say. So this one is okay. Let's do several tests, let's say, test cases. This one will not be the rotating cube, it will be the heads on collision. And we'll move the cube back to the original position and nothing. So this one works as expected. I'm not touching the collision and I'm not bouncing anything, so that's okay. Let's create a wall collision, let's say. So this one will be pretty similar, but the cube will be rotated like so, and we'll move everything a bit further. Okay. Let's see. So this one is actually colliding off the other one, so move them further apart. Okay, so that's a good collision. Let's duplicate this one, move it by 10 also, and apply another collider that I will move here. And this one is a heads-on collision on the second one, so that's why it's not moving. Okay, that's okay. Now I need to check how it would react if there is two collision points at the same time. So double simultaneous collision. Okay, move that further, and for this one I will reset the colliders. I didn't reset the correct one. Should reset this one. Okay, so let's move the first one in the position by 1, the other one by -1, and I will rotate along Y 45 degrees and along -45. Okay, so that should give me a perfectly symmetrical collision with the capsule, and see what happens. So that's not good, because I don't actually want to go over there. I want it to stop. And actually I can see that my position is not exactly correct. I don't want to go through the second wall. Is it related to my distance, my check distance? Because the other ones are correct. This one is working as expected. Actually, no, okay, where is my final position? I need to debug my final position in another color, so that I know where I end up. So let's do this one in black. So my final position is correct, actually. So that's working, because this one is the one I was supposed to do without any collision. This one is the one I'm supposed to reach after the first bounce, and the one I'm actually reaching is the black one that we see here. Is that correct? No, that's not correct. For this one it's not, for this one it's not, and this one is not. So if I have no bounce if I have no bounds at the end, let's do another one. -10. And this one actually has no bounds. Yeah, I'm still doing the initial position. So I'm not taking into consideration the last position update because I'm only updating the position if I have a hit. So if there is no hit, I should say that my distance remaining is equal to 0. I have no more distance to go. And I should update my position to be the position plus the distance. I went through the full distance, basically. So now I'm here, and here, and I'm still here, so it's okay. Okay, so that's working. And now let's take a look at step case, because here this is wall cases, let's say. Did it keep? Yes, so this one is the no collision. And let's duplicate this one, create a step collision. And for this one, so let's move everything -20. For this one, I want to have a step. And that step, I'm not happy with that because I don't want to fly away when I hit a step. So let's add a step parameter to say what is the maximum step height and figure that out. So collide and slide authoring. Can remove that. I want to add a max step height. Okay. Actually, should we handle the slopes first? Let's do the slope first. So max slope. Let's do the slope first. And I will have this one. So in the system, I want to check the surface normal. And check if I should consider the hit as a wall or as a slope. So if I have a hit, I can move up to that distance. That's okay. That's okay. And then we need to is it considered a wall or too steep slope? So for that I need the angle between the surface normal and the up vector or the gravity vector. So let's assume that the gravity vector, the direction is equal to mass.up. Okay. And I want to define the angle between angle between two quaternion. Can I do the angle between something else than two quaternions? Apparently not. Radians for 3. Can I create a quaternion from a loop direction? Forward up. So if I say that my forward axis angle now. How can I get the angle between my surface normal and my up gravity vector? Let's try to ask ChatGPT to see what he comes up with. I have a load 3 representing the slope normal and the load 3 representing the gravity up. I need the angle for the slope. Okay, let's see what it gives us. Normalize both vector, compute the dot product of the two vector. Use the arc cosine function to calculate the angle in radians. Convert the angle from radian to degrees. And it's giving me some codes. Let's try it. So what does it do? Actually, let's put it there. That's the slope normal. It normalizes both vector. I'm going to assume that both are already normalized. Because when I'm taking the surface normal, it should already be a normal vector. And my gravity direction, since I called it direction, it will be normalized. It's mass.up. So that should be okay. So it's getting the dot product. Clamping the dot product. Okay, so let's try to use that in our algorithm. So calculate slope angle. Let's make that extension method. So normalize vector and out float slope angle in degrees. Okay, and return this. And is not happy, return statement missing because it needs to be void. Okay, so surface normal dot calculate slope angle with the gravity direction out slope angle. Okay. And it's a new one, so I need to define it. And if the slope angle is above my collide and slide maximum slope, in that case this should be considered as a wall. So if the slope should be considered as a wall, I should redirect so normal. I should change my normal to make it perpendicular to the gravity vector. So I should project it on the plane that is of gravity direction. Out corrected normal. Okay. That's float 3. And my corrected normal needs to be normalized. Again, to be a normal vector. Tac. And I should basically, can I update that? I should be able to update it. No, I can't. So I need to put that into a variable. Corrected normal equal the surface normal. It's no longer a new one. And now I'm using the corrected normal instead. Okay, let's see what it gives us. So if I take the this example, let's put back the cube at 0. Let's rotate it on the axis by 45 degrees now. 45 degrees. Let's do 45 degrees and let's move it down a bit. Okay. So for my collider, so this one is a slope collision. For my capsule, the maximum slope that I wanted to go up is 30, so it should stop here, I expect. And it does stop. Okay, but if I create slope too steep collision, and this one will be the slope not too steep collision, and for this one I have two options: either I change the collision or the maximum slope, so let's say 50 degrees, and now for the second, where is it? It's here. Actually, there is too many of the others test cases. Disable the other ones. Okay, so this one is working correctly, and actually let's try it live. Okay, so that's working as I expected. So the character cannot go too high, and if if the collision is not in a straight line, it will move along the steepness of the slope. So that's good. And what happens if 0, 0, 0, 0, 0? What happens if it's from above? Okay, it still stops. So that seems to be okay. Okay, good. Not too steep, so let's reset this one. 45, 0, 0, minus 4. No. So that's okay, but I'm flying away now, and what I actually want is to continue along the other side of the slope. So I would want it to actually project downward. For that I need a much bigger cube, because what I need to do is to check the ground. It's moving too fast, in fact. Because I can't check the ground here, but I have no way to anticipate if there will be a stop here. So if I was moving slower, here the speed of the character is ridiculous, because I want it to happen in one step. But if I was moving slower, I would go up here and I would cast down the... I would need to check the ground. So if there is no collision, I should check the ground after that. And if the ground is not too far away, I should snap to the ground, basically. So let's set this one up. Can I? Is that the rescaling? Yes. So let's set this one up for it to snap here. To at least snap on the ground. Let's do that. So that's going to be after I have any bounce. I should do another cast. So I should do this logic. After I've updated my position, so after that, ground snap collider cast input. Okay, and the distance here, it's not the distance actually, it's the vertical parameter, so it's gonna be along the gravity direction times and I need to invert my gravity direction. Is gravity let's do minus 10. Okay. Collector, I still have the collector from before now. The collector is not in the loop, yes, so I can use that here. Okay. What's the issue here? You complain because it was not compiling, maybe. I saved the file and it's not compiling. Collider cast input, it's this one here. Okay. So there is a computation error, line 166. Line 166. I screwed up my... yeah, it's because of this one. Okay. Okay, you are up here now. I can use... Cannot resolve. So why are you complaining? Collector. Yes, it already exists in a higher scope. Okay. So let's create the collector outside of the loop because it doesn't actually change. And no, I need to create it in the loop because otherwise the data in the max fraction and so on will be messed up. So I need to create another one here. Collector foreground it. Okay. Okay. And if I find it, I will change my position to be equal to my gravity direction times 10 multiplied by the fraction so same kind of logic here, but for the vertical component of the gravity. So I just want to move as close to possible as the collision, but not actually on the collision. So I should also have a ground overing distance, something like that, which will be the ground gravity direction times, and again 0.1 f. I'm not sure about the direction because my gravity direction right now is up, and in fact it should be down, so minus up. Let's try it like that and we'll see what it gives us. Clear. Start again. That is not at all what I expected. So what did I do wrong here? I've updated the position. So this up until here it was correct. Then I'm doing a check vertically. Let's do this one in cyan and magenta to check where they are. So here, and magenta is on the ground. Is actually below the ground. So let's not have this one yet. Okay, so no, this one does, so this one is correct. This one is the position of the start, this one is the position of the end of the check. So I am colliding with this one, but the update of my position is not correct. Because I didn't apply the same logic at all. So the travel distance will be my distance, so which is this one, times this collector minus the safety distance that I will add later. And this one should be better. Yes, much better. And now I just need to add again the safety distance. Var round overing this distance, which will be equal to the direction times 0.1f, and I should remove that from the traveled distance. And it's the other way around. Because my gravity direction needs to be negative, in fact. For it to make sense. And when I check the slope, I should use the opposite of the gravity distance. Okay, that makes more sense. That's much better. So we have several cases that are working properly. What's happening now if I do a step? Step collision. Let's remove the rotation. Or okay, let's move everything. Oops. Disable the other one, and for this one, yeah, I'm actually moving down quite a lot, but what I want to check is okay. This one is a max, exceeding the max slope here on the normal. So this one is a good example because if the step is low enough, it will work naturally. But if it's too high, I will stop at the step, but I do want to be able to walk up a higher step, let's say. So let's add a bit of comment to this section. Since the last bounce did not produce a hit, we need to update the position to the with the distance checked. Okay. To avoid having the character fly up when it collides with a slope or step, we need to check the ground distance. Actually, let's do how do we know how far we need to check? Oh no, it's hard coded, but distance to check. That one for now is 10, but we'll need to update it. To do, find a way to compute the necessary distance to check. Because we can't just take the step. Step height. Because if we just take the step height, this is not going to be enough. Actually, we would need to check the distance from the previous. Do we need to check it after every bounce? That would cost a lot of checks. Because we need to know if it's potentially a step. And if it's potentially a step, we need to set it at the edge of the step and continue. So actually it's the step checking. So this one will be just for snapping down a slope. So for this one, it seems to be working for the step, but actually for the step, we need to check for every bounce. We need to define if that is a potential step. So let's add now. Let's add back the step parameter. Max step height. Okay. And in the collide and slide system, we do our check. And before we travel the distance, how should we do that? I still want to go up to the step. So I still need to move towards that. Here I'm checking, so I think it's kind of the same thing that for the slope. I'm checking if the slope is too steep. If it's too steep, it should be considered a wall, but maybe it's a step or a step. So we need to check if it's a step. So to check if it's a step, we need to get the position of that hit. and we need to have the distance between the vertical distance between my current position and that it. So I need to have position minus the it position minus my new position. And I need to project that on the vector. So mass dot project this one along the gravity. This one will give me the step, the potential step height. Okay. And if this one is below the collide and slide maximum step height, I need the length of this one. Let's square it to avoid mass dot square to avoid the square root. And if the step is small enough, I need to check if I have sufficient space to step up. So I need to do a cast. Step cast input of my collider from the position, not from the position. I need to do it from the hit position, no, up to the hit position. I should be able to end at this position. And I need to start above that hit position and go up vertically the distance of my max step height. Or I should start at my current position. I should start at my current position and then cast forward horizontally. So I actually need the step height. So let's not square it. And I need to start at my current position minus going into the opposite direction of the gravity direction multiplied by the height of my step. do a check. For my distance, my remaining distance. On the horizontal plane. So I need to project the leftover distance, which I compute here, so that's my distance. So this one I need to project it on the plane that has the normal of gravity. And out float 3 projected step direction. And I need to do it from this position plus this one. So let's actually debug these. Let's create 2 more debugs. I'm starting to run out of colors. Stepcast this time. And what color do we have left? Gray, 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 white. Let's do white for this one and gray. Okay. So black, white and gray are not working well together. Let's remove the black one. Let's remove the other cast debug. Control-S. I'm not casting at all. Because I haven't set the step height. I'm no longer debugging those. Am I? Yes, I'm still debugging those. Okay. Okay, so the casting is cold, but not when I expect. Let's re-enable the normal. Okay. What's happening here? Debugging the step height. Zero virgule 004. What? I don't understand this. It seems to be from the center of the capsule. So there is something problematic with the setup of my capsule, because the center of the capsule, yeah, the center is not was not at the correct place for this to work. So now I have no hit. Okay, it's going up, and down. So this is not giving me the height I'm expecting. Let's not do that check at all. So we do it every time, and we'll see. This is really not what I'm expecting. So I need to figure a way to get the step height that is correct, because here I'm like at 0.4. Let's close it. 0.44, and if I go up a bit, the step height actually reduce. So it's computed from the center of the capsule and not the bottom root of the capsule. And if I change this, it's no longer hitting it. The display is not correct anymore. My debug display is not correct anymore because the actual position is higher than that. I actually need a capsule that is not centered around zero, around the center of mass. So I need to figure out the step differently. I need to figure this part differently because that's the word space, but that's the center of the capsule and not the root of the capsule. And if I wanted to work with any collider, where is my collider? Collider O dot mass properties, mass distribution, rigid transform, position rotation, not good, volume, I have nothing here. Mass properties, memory size, type, collision is unique. So I need to find a generic way to get the, let's say, bottom of the collider. Or I need to constrain it to a capsule collider. I need to constrain it to a capsule collider and then know the height of the collider. Because if I change this to be 1, how could I debug Can I access this one somewhere? Center. Let's look at the entity capsule collider in entity view. Physics collider geometry. Position 1. And if I go back here and say 05, back to the runtime view, 0.5. So mass property, mass distribution, transform, and I can get the offset here. So that's my position plus collider dot value dot mass properties, mass distribution, transform, position. Is it here that I should put it? I hope so. Okay. Let's look at the debug. 09 30. Okay, so that seems to be okay. Now I will do that only if I'm not reaching the maximum height. And the maximum height is ridiculously low. So I need to update it to something more realistic. 0.5. Okay, so now I'm trying. And the gray one is at the end of my cast. I'm not casting the correct. This is still not casting the correct one because I wanted to cast from up here, just above the step, which I'm not. And I'm moving away. The higher the step is, the further away I am. So position. So it's the same thing, in fact. I should also have this. Is that it? Yes, that seems correct. So let's re-enable the position I'm supposed to reach. And now I did step up the step. Even if the step is like quite high, I can step up. I would be able to step up. Okay. So it's a bit troublesome to have to check the offset of the collider. But for the character controller later on, since I will probably create the collider myself and constrain it to a capsule collider either way. So it will be simpler to just say, okay, the character is too high, and I will have the collider as I expect it from the position to be the root. So I can probably let's say we assume it's a capsule collider, and in the collide and slide will they make the public float character height. Okay. And that will make things a bit simpler. Because my position will be changed by collide and slide dot character height divided by 2 alpha of the height times the gravity direction opposite. Tac. Where did I put the other one? It was just there. Apparently this was just there. Okay. Doesn't seem correct. Okay, no, there is something not correct with this step logic. Let me try something else also that I want to check. I'm not actually doing the cast, so I can't check it. But I wanted to check that I could not move to a location where the player is intersecting with, let's say, another plane. So for instance, if it's like that, it should not be able to step up, basically. So that's what I wanted to check, but I need to do the cast actually to check that. Okay, I think we did quite a good bit of progress. We have several cases working. If I re-enable them all, we can see that really there is one that needs to be moved. And I need to re-enable all my debugging row. Oops. No, it was work commands. Okay, and these two, and this last one. Okay, so if I go up a slope, I can be sticking to the slope, and I will actually need to maybe do some checks on that to not stick to the ground at the end of a cliff or something like that. The step is work in progress. This one is too steep slope, so I'm stopping here. This one is no obstacle, so I do reach the end of the position, the end of the distance I want to go through. Heads-on collision, I will stop at the collision, just like for the slope. Single bounce, I am bouncing correctly. Two bounce, I am bouncing correctly. And actually, maybe I will need to, for the character controller, make sure that I'm actually not moving in a direction that is opposite to the one the player wants to move. So stay stuck over there, basically. Maybe that's something we can do quickly, actually. And this one is the double simultaneous hit, let's say. So for this one, let me check this one, duplicate. Let's call it dead end collision. And I will change this one to have something that is like that. It's okay. I'm not sure I want to have this behavior. I was going more for something like a slightly angled one. Something like that. And actually rotate both of them. Okay, so this one is continuing in the correct direction and this one is a dead end. So in the case of the dead end, yeah, the magenta ones are the ground checks that are not hitting anything in most of the cases. And since I'm not hitting anything, I'm keeping my current position, so that's good also. Now for this one, since it's a dead end, I need to check. Let's assume that the movement direction is the mass.normalize direction of the distance. And now I need to check when I get bounce. I correct the normal, corrected normal. Project it on the plane direction. No, the corrected normal was calculated here. so it's calculated here actually. So here I'm in the case where I hit a wall. So I will slide. I'm not sure if I should check it also if I'm not in hitting a wall, let's say, but is there a situation where I can have the character hitting a plane? He'll be climbing it. Actually, I need to have a check, like let's create a case. Test case. If this one is like updated like that, and my case is not dead end collision. Okay, that's better. So if this one is updated, these are rotated enough to cause the dead end scenario. So in this scenario, that's because the maximum slope is 0. So I should check it every time, in fact. Because here I want the character to reach this position. So we will cast over there, but it's hitting this plane, so it's casting over there. Yeah, I will check every time I bounce if the next bounce would make me go in the opposite direction of the what the player wants. So if my movement direction this one needs to be projected on the gravity plane. So let's do distance dot project on plane. Plane normal will be the gravity minus the gravity direction, and I will out the float 3 movement direction, and this one will be normalized as so. So that's my movement direction, and every time I'm redirecting corrected normal, we need to reorient the movement along the plane to actually be able to move. And the project leftover distance, so here I need to mass dot product between this direction and the leftover distance. If this is below 0, it means that the two vectors are not going facing the exact or the same general direction. And if so, then the distance I need to do a mass dot select, and false will be my distance, true will be float 3 0, and the test will be this one. So if they are not going in the same direction, I will get 0. If they are going in the same direction, I will get my leftover distance. Let's look at what it gives us for the dead end. Recompile. Let's look at the dead end. That's not working as expected. The black one should be in the middle here. That's not the dead end. Yes, that's the dead end. Okay. That's not working. Did I inverse the test? No, I didn't actually make the code compile, so okay, let's go back to the dead end, and it's still not working. I want it to stop here. Let's try the other way around. Not exactly what I want. Not exactly what I want. This one makes more sense. Ah, okay, that's working. Probably a issue in the recompilation, but now in the case of a dead end, I'm staying stuck on the corner. So that's a good case. And for this one, I was trying to replicate the same kind of things, but I'm not actually succeeding. Because in case of a slope, I want the same thing to happen. But I don't think it can happen, in fact. Why would a slope make me move backwards? It shouldn't be able to do that. So that means this check could be done only in case of a wall. But it's working like that, so let's worry about the optimization later. I'll just leave a to-do here. This to-do check this dead end logic can't be only when hitting a wall. Okay, I think that will be it for today. We have done quite a few cases that are apparently working correctly. There are still some stuff to handle, like the step case, the maximum, let's say, slope or snapping distance to the ground. And yeah, we'll check that for the next stream. I will let you know when that next stream will be. Probably next week, like Monday or Wednesday, I don't know. So if you want to get notified, you can subscribe. You can also follow me on Twitter or join the Discord. I'm also on Blue Sky. And again, if you want to support the channel, you can do so with the affiliate links that I will try to send in the chat right now. And it's not letting me send them, but up in the description at the beginning of the chat, there is links. There is also links in the description if you want to support me with the affiliate program of Unity, of Humble Bundle, or you can support me directly on Ko-fi if you want. There is a link in the description of the page. And if you want to support me without buying or paying anything, you can check out my dots tutorial series to learn about Unity dots, Unity ECS. And it will support me also because I'm trying to reach the 4,000 watch hours on the channel. So if you be kind enough to take a look at them and share them if you like the content, and that would be greatly appreciated. Thank you again. Sorry again for the mic at the beginning, and thank you, Vadim, for letting me know, because otherwise it would have been a terrible stream. So thank you again, and see you in the next stream. Bye.